I'm Dixon, Assistant Professor of Mathematics. I'm going to present the derivation of Pollaczeck Kintchine formula. The main objective of this formula is to find the average number of customers in the system. Now the basic notations are given as M, it is a Poisson arrivals, G general output distribution, and it is a single server model with infinite capacity, and GD is general service discipline. It may last come first service and first come last served, service in random order. And other notations we are going to use here is the number of customers in the system at time t, and n dash the number of customer in the system at time t plus capital T. So from that we can easily say that capital T is the service time. K, the number of customers arriving during the service time T. So this is our basic notations, and we have to define some functions, delta, and from that we have to derive n delta. Before that, from the definition of n dash we can get k if n equal to 0. If n equal to 0, clearly we can see that there will be k customers, and if n greater than 0 also, we have to reduce one person from n, and we can get n minus 1 plus k. This is for n dash. Delta is 1 if n equal to 0, 0 if n greater than 0. Then n delta we can get, if n equal to 0, then delta value is 1 but n is 0, then we can get n equal to 0. For n greater than 0, delta is 0, therefore n delta is always 0. So we can get n dash as n minus 1 plus delta plus k. So this is the first equation. Now if we take expectation, we can get E of n dash equal to E of n minus 1 plus E of delta plus E of k. This is the second equation. At the steady state, it does not depends on time, so we can get E of n as E of n dash and E of n square as E of n dash square. So we can take this as third equation. So from 2, see the second equation, E of n is equal to E of n dash, so we can cancel those two. We can get E of delta as 1 minus E of k. If we take squares on both sides of first equation, we can get, or we can simplify, and we can get the step 2n 1 minus k is equal to n square minus n dash square plus k square plus delta into 2k minus 1 minus 2k plus 1. And if we take expectations on both sides, we will get, after few steps, E of n as E of k square plus E of k minus 2e square of k by 2 into 1 minus E of k. This is the fifth equation. So we almost reached the Pollaczeck Kintchine formula. Now we have to find E of k square and E of k. We know that E of k with respect to capital T is equal to lambda t. E of k square by t as lambda square t square plus lambda t. So variance of k with respect to t is equal to E of k square t minus E square of k by t. This equation we know well. And E of k, this is a continuous random variable, so E of k is equal to, by definition, 0 to infinity E of k by t f of t dt. So if we substitute the value, we can get 6. Similarly, we can get the value for E of k square. We will get lambda square E of t square plus lambda E of t, but we already have V of t as E of t square minus E of t the whole square. From that we can get lambda square V of t, lambda square E square of t plus lambda E of t. So if we substitute 6, 7 in 5, we will get Ls as E of n is equal to lambda square v of t plus e square of t plus 2 lambda into e of t into 1 minus lambda e of t by 2 into 1 minus lambda e of t. So at last, if we substitute v of t as sigma square and e of t as rho by lambda, we will get ls, that is equal to e of n as rho plus lambda square sigma square plus rho square by 2 into 1 minus rho. This is known as Pollaczeck Kintchine formula. We can write it short term as pk formula.